Hello everyone, welcome to Saimedha KOTI Hyderabad. In this video, I would like to discuss about power equations of the three-phase induction motor. In this topic, I will discuss short notes and concept through the question. And this class is useful for Andhra Pradesh State Electricity Board AEE exam and Telangana Genco Transco Discom AE exam. Let's start from the short notes, and after that we'll discuss concept through the questions. And these short notes are also called observations, key points or possible questions from power equations of the three-phase induction motors. So that is short notes. Short notes are key points or observations or possible questions from power equations of the three-phase induction motors. So one of the question, how to find out the input power of the three-phase induction motors. And first one we will discuss. One is the input power of the three-phase induction motor, and this is also called, another name of this input power is also called the stator input power. So this is the stator input power of the motor. So this value can be find the √3 times of the V1 or VL IL, okay, cos theta 1. So where VL is the supply line voltage and IL is the supply line current and cos theta 1 is the input power factors. So in this case, so where the VL is, what is a VL? So VL is input or supply, the supply line voltage, and IL is supply line current, and cos theta 1 is the stator power factor. It is also called the input power factors. So this is the input power factor of the motors, or it is also called the stator input power. So this one is a VL √3 VL IL cos theta 1. And next one, how do we find out, okay, stator the losses? Okay, this one is the stator losses. There are two types of the stator losses. One is the stator copper losses and stator iron losses. The stator losses is equal to, so how do we get stator losses? Second observation, so that is stator the losses. The total stator losses are equal to the stator copper losses and stator iron losses. The stator copper loss, the plus the stator iron loss of the machine, stator copper losses and stator iron losses. So from the stator losses, so we can find out the stator output. And third one, so this is also the stator output power. And this stator output power, another name of stator output power, and it is also called the rotor input power also. So rotor input power, the stator output power is also called rotor input power. Other name of this one is also called air gap power. So this another name of the rotor input power is also called the air gap power. Stator output power is equal to the stator input power. So this input power, the minus, okay, stator losses. So what are the total stator losses? Stator input power minus stator out. And this rotor input power can be found in terms of the rotor parameters also, other formula to find out. So this is stator in stator output power in terms of the stator input power and the stator losses. సో ఒకవేళ స్టేటార్ ఇన్పుట్ పవర్ అండ్ స్టేటార్ లాసెస్ ఇచ్చినప్పుడు ఏ విధంగా స్టేటర్ అవుట్పుట్ పవర్ క్యాలిక్యులేట్ చేయాలా, ఆ రోటర్ ఇన్పుట్ పవర్, ఇట్ ఈస్ ఆల్సో కాల్ ద రోటర్ ఇన్పుట్ పవర్ అండ్ ఇట్ ఈస్ ఆల్సో కాల్ ఎయిర్ గ్యాప్ పవర్. సో అలా కాకుండా కొన్నిసార్లు కొన్ని క్వశ్చన్స్లో ద రోటర్ పారామీటర్స్ ఇచ్చి ఎలా రోటర్ పారామీటర్స్ ఇచ్చినప్పుడు ద రోటర్ ఇన్పుట్ పవర్ అనేది ఏ విధంగా క్యాలిక్యులేట్ చేయాలి. సో నా ఫోర్త్ ఫార్ములా or fourth observation here, the fourth one, rotor input power or rotor input power is equal to the 3 into I2 square R2 by S. So 3 into I2 square R2 by S, where I2 is a rotor current per phase. So in this case where the I2, okay, where R2 is a the rotor resistance, the per phase and I2 is the rotor current per phase, where S is the full load slip of the motors, full load the slip of the motor. So we know that how to calculate the slip of the motor, ns minus n divided by ns. This is the rotor input power. And the fifth one, so another observation from the power equations, so that is next one is rotor the copper losses, how to calculate the rotor copper losses here. And this rotor copper losses are also is equal to the 3 into I2 square R2. So 3 into I2 square R2. Now unless otherwise specially mentioned, iron losses of the induction motor in the sense the stator iron losses only. So rotor iron losses are very small, so neglected. So this rotor, sixth point here, the rotor iron losses, okay, this iron losses are very small, very small, so this very small, so neglected. So neglected. So rotor iron losses are low, so that it is a neglected here. So unless otherwise specially mentioned, the rotor iron losses of induction machine in the sense the stator iron losses only. And next possibility of the question, gross mechanical power output. So gross mechanical power, the output of the motors, and how do we calculate the gross mechanical? So this gross mechanical power output is also called, so another name of this one is rotor output power, other name of the gross mechanical power. So it is also called the rotor output power, and it is also called so electrical equivalent of, okay, electrical equivalent of the mechanical, so mechanical power. Sometimes we have a question in terms of other names. Gross mechanical power output is also called the rotor output power. It is also called electrical equivalent of the mechanical power. And how do we calculate this one? So 3I2 square R2 into, so 1 by S minus 1. So this one is the gross mechanical power output, where I2 is the rotor current per phase, where R2 is the rotor resistance per phase 1. Now sometimes we have a question, the rotor copper losses in terms of the rotor input power. So next one, rotor gross mechanical power output in terms of the rotor input power. And this one is sometimes there is a one question from relations point of view. So that is 8th observation. So that is rotor input power. This rotor input power, so is to the rotor copper loss, that is to rotor output power. Sometimes it is also called gross the mechanical power output, the gross mechanical, the power output of the motor, rotor input power, and it is equal to 1 is to S is to 1 minus S. So this relation also important. The rotor input power is to rotor copper losses is to gross mechanical power output. So is equal to 1 is to S is to 1 minus S. And next possibility of the question from here. So sometimes we have a question, what is the relation between the rotor copper losses and rotor input power? So this rotor copper losses are is equal to rotor copper loss equal to and S times of the rotor, the input power of the motors, S times of the rotor input power. Now there is a one question here. So we know that how do we calculate the slip of the motor? The slip is calculated. There are sometimes we have a question. So note points here, first point. So we know that slip is equal to ns minus n by ns. This is the one method to find the slip of the motor. And there is a one more formula to find out the slip of the motor. So that is Fr is equal to S into F. So that S is equal to the Fr divided by F, rotor frequency by stator frequency. And one more formula to find out the slip of the motor. See here. So S is equal to rotor copper losses, rotor copper loss, the divided by the rotor input power. సో ఒకవేళ స్లిప్ మనం మూడు రకాలుగా కనుక్కోవచ్చు. అంటే ఈ ఫార్ములా యూజ్ చేయొచ్చు. ద ఎస్ ఈజ్ ఈక్వల్ టు ఎన్ఎస్ మైనస్ ఎన్. ఒకవేళ రోటార్ ఫ్రీక్వెన్సీ స్టేటార్ ఫ్రీక్వెన్సీ ఇచ్చినప్పుడు ఈ ఫార్ములా యూజ్ చేసి కనుక్కోవాలా. అలా కాకుండా కొన్నిసార్లు రోటార్ కాపర్ లాసెస్ అండ్ రోటార్ ఇన్పుట్ పవర్ అంటే పవర్ ఈక్వేషన్స్ ఇస్తాడు. అలాంటప్పుడు స్లిప్ ఏ విధంగా కనుక్కోవాలంటే ఎస్ ఈజ్ ఈక్వల్ టు ద రోటార్ కాపర్ లాసెస్ డివైడెడ్ బై ద రోటార్ ఇన్పుట్ పవర్ అని క్యాలిక్యులేట్ చేయాలి. సో ఈ విధంగా డిఫరెంట్ వేలో కూడా కొన్నిసార్లు స్లిప్ అడిగే ఛాన్సెస్ ఉంటుంది. సో స్లిప్ అనేది ఈ ఫార్ములానే కాదు. సో దేర్ ఆర్ 3 ఫార్ములాస్ టు ఫైండ్ అవుట్ ద స్లిప్. సో దట్ ఈస్ వన్ ఈస్ ఎస్ ఈజ్ ఈక్వల్ టు ఎన్ఎస్ మైనస్ ఎన్ డివైడెడ్ బై ఎన్ఎస్, where S is equal to Fr by F, where S is equal to rotor copper losses divided by rotor input power. And next possibility of the question from this concept, the 10th one here, and gross mechanical power output of the motor. How do we calculate? So gross, the mechanical, so power output of the motor, so power output of some motor, so induction motor. So power output of induction motor is equal to the 1 minus S times of the rotor, the input power. This is also one of the question. Gross mechanical power output of the motors. Now next possibility of the question, that is 11th one here. Approximate efficiency. So this approximate efficiency of the 3-phase induction motor. Efficiency of 3-phase induction motor, and other name of approximate efficiency, it is also called the rotor efficiency. Sometimes the rotor efficiency is called approximate efficiency of the 3-phase induction motor. So it is equal to 1 minus S always, or otherwise n by ns. Suppose in terms of the slip is equal to 1 minus S, in terms of the speed is equal to the n by ns. Suppose if we want to find out percent efficiency multiplied by 100, this is a per unit value 1 minus s or n by ns value. And next possibility of the question, that is 12th one. So how do we calculate efficiency of the 3-phase induction motor? So this exact efficiency, the efficiency of percentage, the efficiency of 3-phase induction motor. Or before that, so we can find one more formula, that is gross net mechanical power output. How to calculate net mechanical power output of the motor? Other name of this one is also called shaft power of the motor. How do we get net mechanical power output? So gross mechanical power output of the motor minus mechanical losses or friction and windage losses, mechanical losses. If we remove the mechanical losses from the gross mechanical power output, so we will get the net mechanical power output of the motors. And next 13th question, so how do we calculate efficiency of the 3-phase induction motor? Percentage efficiency of the 3-phase induction motor, so induction motor is equal to, so that is the output power, so that is mentioned on the nameplate area, so that you can find the net mechanical power output of the motor. So divided by, so net mechanical power output of the motor, the plus, so here constant variable losses, the losses, and plus constant losses of the motor multiplied by 100. So variable losses can be obtained. So this was obtained by using, the variable losses in the 3-phase induction motor can be obtained by using the blocked rotor test. The test of the 3-phase induction motor. Test data nunchi మన బ్లాక్ రోటర్ టెస్ట్ తెలిసి వేరియబుల్ లాసెస్ ఫైండ్ అవుట్ చేయొచ్చు. తర్వాత నో లోడ్ టెస్ట్ నుంచి కాన్స్టాంట్ లాసెస్ ఫైండ్ అవుట్ చేయొచ్చు. సో దిస్ వాస్ గివెన్ ఆన్ ద నేమ్ ప్లేట్ డీటెయిల్స్ ఆఫ్ ద 3-phase induction motor. So if we know the variable losses and constant losses, so we can find out percentage efficiency of the 3-phase induction motors. Okay. So these are all possible questions from the power equations of the 3-phase induction motor. Now we will discuss about what are the possible questions or concept through the questions, right? We'll discuss some question based on this concept, and this is all short notes or key points or observations, possible questions from 3-phase power equations of 3-phase induction motors. Let us solve the question number 1. In a 3-phase induction motor, if PZ represent the air gap power, then rotor ohmic losses and, so this is, and power, mechanical power developed is, options are given like this, and air gap power is nothing but, air gap power is also called the rotor input power, another name of this one. So rotor input power, and it is also called another name of this one, the stator output power also, stator output power. And we required rotor ohmic losses. Rotor ohmic losses means the rotor copper losses. So rotor, the copper loss is equal to, rotor copper losses are equal to the S into the rotor input power of the motor. This rotor S is equal to rotor input power is, so this was given, so it is a PZ indicates the air gap power, so that S into PZ. And next another one, mechanical power developed, that is nothing but gross mechanical power output of the motor. So mechanical, the power developed, so developed is equal to, so this is equal to the 1 minus S into the rotor input power. So this rotor input power is equal to 1 minus S into PZ. So now select the correct option, rotor ohmic loss S into PZ and 1 minus S into PZ. Okay, so option the 3 is correct for this question. And next let us solve the question number 2. The rotor power output of the 3-phase induction motor is 15 kilowatts. The rotor power output of the motor, so is a 15 kilowatts. The rotor power output is nothing but gross mechanical power output. So this mechanical power output of the motors, and corresponding slip is equal to 4%. The slip is 4%. And what is required in this question? The rotor ohmic losses are required. Option 1 was given 600 watts, option 2 625 watts, and option 3 650 watts and 700 watts. The 4% of the slip means the slip is equal to, slip in the percentage, is equal to 4%. But slip in per unit value, how do we calculate the slip in the per unit value? That is denoted by, yes, 4 by 100, so equal to 0.04. So this is a slip in per unit value. So we know that the rotor input power is equal to rotor input power, so that is to rotor copper losses, that is to gross rotor output power or gross the mechanical power output, gross the mechanical power output of the motor, power output, so that equal to 1:8 S is to 1 minus S. 1 is to S is to 1 minus S. ఇప్పుడు ఇక్కడ నుంచి ఈ రెండింటి మధ్యలో రిలేషన్ కావాలి మనకు. రోటార్ కాపర్ లాసెస్ కావాలి ఇన్ టర్మ్స్ ఆఫ్ ద రోటార్ అవుట్పుట్ పవర్ ఇచ్చింది కాబట్టి. సో దేర్ ఫోర్ సో ఫ్రమ్ హియర్ వీ కెన్ రైట్ సో రోటార్ కాపర్ లాసెస్ ఇస్ ఈక్వల్ టు రోటార్ కాపర్ లాసెస్ divided by gross mechanical power output of the motor. So that is equal to, so rotor divided by, so this value is equal to S by 1 minus S. So from here we can get rotor copper losses equal to S by 1 minus S the into sub rotor output power. Gross mechanical power output is nothing but the rotor output power of 3-phase induction motor. What is the value of S? S is equal to 0.04 and divided by 1 minus 0.04 multiplied by, so this is 15 kilowatts, the 15 into 10 to the power of 3. So therefore 0.04 divided by 0.96 multiplied by 15 into 10 to the power of 3. So let us simplify this. So this value is equal to 625 watts. So answer for this question, so it is a 625 watts is the correct. So ila answer cheyali. And next question number 3, a 3-phase, okay, it is a 3-phase 50 hertz induction motor that takes the power input of 30 kilowatts at its full load speed of 1440 rpm. So this is power input of the motor 30 kilowatts and speed of the motor is equal to 1440 rpm. Total stator losses is equal to 1 kilowatts. The slip and rotor ohmic losses, we required slip of the motor and rotor ohmic losses at full load R. Option 1 0.02 comma 600 watts. Option 2 0.04 comma 580 watts. Option 3 0.04 comma 1160 watts. Option 4 0.04 comma 1200 watts. And let us calculate first one, slip of the motor. 3-phase 50 hertz and the 1440 rpm is given, but we don't know how many number of the poles. Suppose here, and slip of the motor, first synchronous speed is equal to, so here 120 f by the p. So now this is equal to ns 120 the 50 hertz. So number of poles is equal to 4-pole machine and 3-phase here 4-pole so machine. And it is a, otherwise we have to be consider 4-pole also. ఇవ్వకపోయినా కూడా 1440 rpm ఇచ్చిందంటే కంపల్సరీ ఆ మిషన్ అనేది ద 4 poles తో డిజైన్ అయి ఉంటుంది 1440 rpm. అప్పుడు 4 poles అన్నప్పుడు దిస్ వాల్యూ ఈజ్ ఈక్వల్ టు సో 1500 rpm వస్తుంది. మరి స్లిప్ ఎలా అనుకుంటాం? S ఈజ్ ఈక్వల్ టు ns డివైడెడ్ బై ns. సో ఈ విధంగా వేయచ్చు. సపోజ్ స్లిప్ ఈజ్ ఈక్వల్ టు, సో దిస్ వన్ ns మైనస్ ద 1500 minus 1440 divided by 1500, so is equal to 0.04. So slip we got, and we know stator input power and rotor stator losses, and therefore rotor, okay, rotor input power, stator output power, the stator output power of the motor output power, it is also called the rotor input power. So this rotor input power of the motor, so it is the rotor, the stator input power of the motor minus, okay, minus stator losses. What are the stator losses here? Now it is equal to 30 kilowatts minus 1 kilowatts. Okay, it is equal to 39 the kilowatts. This is the rotor input power, but we required rotor copper losses. How do we calculate the rotor, the copper losses of the motor? The rotor copper loss is equal to the S into the rotor input power of the motor. The where S is equal to 0.04 multiplied by the rotor input power. So this rotor input power is equal to the 39 into 10 to the power 10 to the power of 3. So that is equal to the 4 in 40 into 39. Just simplify. So by solving you will get, so this value is equal to 1560 the watts. So 1560, actually the 1560 the 1560. So that option 3 is a correct, 0.04 the into 1560 watts. And next one, question number 4, the power input to a 415 volts 58 6 pole 3-phase induction motor is running at 975 rpm, is a 40 kilowatts. The stator losses are 1 kilowatts and friction and windage losses are 2 kilowatts. The efficiency of the motor is option 1 92.5%, 91%, 90.06%, option 4 is a 88%. And input power of the motor is given. Let us calculate the slip of the motor. First one, synchronous speed. Let us calculate the synchronous speed of the motor. Ns is equal to, so 120 F by P. So 120 50 hertz divided by 6 poles. So this value is equal to 1000 rpm. And slip of the motor is equal to Ns minus N by Ns. The 1000 minus 975 rpm divided by 1000 rpm. So now it is equal to 975 rpm, and here 0. So this one is 0.025. Let us verify once again. Yes, 0.025. So this is the slip of the motor is equal to 0.025. And we know that input power of the motor is equal to 40 kilowatts. Therefore, the stator output power, and it is also called, other name of this one is the rotor input power or gross mechanical power output. So that is equal to stator input power, the input minus stator losses. So stator losses are given. Stator losses, that is equal to 40 kilowatts minus 1 kilowatts is equal to 39 the kilowatts. This is a gross mechanical power output, rotor input power. Now let us calculate the gross mechanical power output. How do we calculate the gross mechanical power output? So now this is equal to 1 minus S into the rotor input power. So this rotor input power. So 1 minus this is equal to 0.02 pi. So 0.045. And rotor input power is equal to 39 kilowatts. Okay, 39 kilowatts. Now let us simplify now. 38.025 kilowatts is the gross mechanical power. And if you want to find out efficiency, first let us calculate a net mechanical power output. Net mechanical power output of the motor, so is equal to gross mechanical power output, minus mechanical losses. So now this is equal to 38.025 kilowatts minus the 2 kilowatts. So therefore it is a 36.025 kilowatts. This is net mechanical power output of the motors. After getting this, so we can find out efficiency. Percentage efficiency is equal to, so here output power of the motor, net output power. So net mechanical power output, of the motor, so divided by, so input power of the motors, the input power multiplied by 100. So this percentage efficiency is equal to, so net mechanical power 36.025 divided by 2 pi kilowatts, 40 kilowatts multiplied by 100. So by solving this we will get, so this value is equal to 90.06%. 90.06% is the right answer for this question. So 90 point, here 92.5%, 91%, 90.06%, 88%. So that option 1 is correct for this question. And next possibility of the question is from this concept, it is the fifth one. See here, a 3-phase 50 Hz 6-pole induction motor runs at 960 rpm. Stator losses, stator core losses, rotation losses are neglected. Percentage efficiency of the motor is, and here mention that this percentage efficiency is equal to, so all are neglected, but that is nothing but percentage efficiency of the motor is nothing but approximate efficiency of the motor. So this value is equal to 1 minus s. 1 minus can be written as the n by ns, and it is equal to n by ns is a, where ns can be calculated. Ns is equal to 120 f by p. So now it is equal to 120 50 Hz 6 poles, that is equal to 1000 rpm, as 1000 rpm synchronous speed. So therefore 960 divided by 1000 rpm, so 1000 rpm, but percentage efficiency is equal to 960 divided by 1000 rpm multiplied by 100. 0 is a cancel, so finally we will get 96%. So answer for this question, option 1 is correct. And next, see here, and in Saimedha KOTI, Hyderabad, through SpaceGate, we are providing online course. So this online course details, what are the content we have in the online course? So one is, first one, topic wise video lectures. We have a topic wise video lectures, and we have previous gate questions with the video solutions, and along with you will get previous ESC questions with the video solutions, previous TSPSC questions with the video solutions, previous AP PSC questions with the video solutions, next previous other state PSC question, the standard textbook questions, topic wise practice self test, topic wise live test, and also live grant test. So these are the exactly in the content we have pre-recorded course in the SpaceGate. And the course price details point of view for AE and AEE. సో ఆన్లైన్ కోర్స్ మీరు తీసుకోవాలనుకుంటే కేవలం 9000 రూపీసే. మరి అదేవిధంగా ఈ 9000 రూపీస్లో ప్రీ రికార్డెడ్ కోర్స్తో పాటు సో లైవ్ క్లాసెస్ కూడా మీకు ప్రొవైడ్ చేయడం జరుగుతుంది. సో లైవ్ క్లాసెస్, అదే లైవ్ నువ్వు ఒకవేళ లైవ్ అటెండ్ కాకపోతే తర్వాత కూడా రికార్డెడ్ అవుతుంది, ఆ రికార్డెడ్ వీడియోస్ కూడా చూసుకోవచ్చు. అంటే ఆల్రెడీ ప్రీ రికార్డెడ్ వీడియోస్ అలాంగ్ విత్ ద లైవ్ క్లాసెస్ అండ్ కాస్ట్ ఎంత ఆన్లైన్ కోర్సు ప్లస్ ప్రీ మెటీరియల్ తీసుకున్నప్పుడు సో ఇది కేవలం 9000 రూపీస్ మాత్రమే. మరి ఒకవేళ మీరు ఆఫ్లైన్లో అటెండ్ కావాలంటే, ఆఫ్లైన్ ప్లస్ ఆన్లైన్ కావాలంటే 27000 రూపీస్. సో ఇది మనకున్న యాప్ పేరేంటి, SpaceGate యాప్. సో మరి ఈ యాప్ డౌన్లోడ్ చేసుకున్న తర్వాత ఇక్కడ కనిపిస్తున్న నెంబర్ కాల్ చేయండి, 9848692598. సో మరొక నెంబర్ 9849713551. సో ఈ నెంబర్ మా కోఆర్డినేటర్ శశికాంత్ వాల్మీకి సార్ నెంబర్. మీకు ఎలాంటి డౌట్ ఉన్నా ఈ నెంబర్ కాల్ చేస్తే సార్ క్లియర్గా మీకు ఎక్స్ప్లెయిన్ చేస్తాడు. మళ్ళీ ఒకసారి నెంబర్ చెప్తాను, 9848713451. సో ఈ నెంబర్ కాల్ చేయండి, మీకు ఎలాంటి డౌట్స్ ఉన్నా సార్ వివరంగా మీకు ఎక్స్ప్లెయిన్ చేస్తాడు. సో ఆల్రెడీ లైవ్ క్లాసెస్ స్టార్ట్ అయ్యాయి, ఆల్రెడీ 5 days అయింది సిగ్నల్స్ అండ్ సిస్టమ్ సబ్జెక్ట్ జరుగుతుంది. సో కంటిన్యూస్గా 1000 hours అనేది ఒక ముందే ప్లాన్ చేసి ప్రతి సబ్జెక్ట్కి ఎన్ని అవర్స్ ఉండాలి అనేది ఒక సిస్టమేటిక్గా రన్ అవుతున్న లైవ్ క్లాసెస్ అంటే ఏదో ఒక సింపుల్గా ఒక 30 hours 40 hours ఇట్లా ఇచ్చేసి కంప్లీట్ చేయడం కాకుండా సో సఫిషియెంట్ అవర్స్ ప్రొవైడ్ చేస్తూ దాన్ని ఆన్లైన్, ఒకవేళ నువ్వు ఆఫ్లైన్ క్లాస్ అటెండ్ కాలేకపోతే వాళ్ళ నువ్వు లైవ్ క్లాసే పర్ఫెక్ట్ విన్నావంటే అది ఆఫ్లైన్ క్లాస్ ఏ విధంగా ఉంటుందో అలా ఉంటుంది. సో ఈ మంచి అవకాశాన్ని యూటిలైజ్ చేసుకుంటారని ఆశిస్తూ మీ భాను సార్. థ్యాంక్ యూ వెరీ మచ్.